We'll proceed in summation to integral calculus. Oh, very difficult topic we have taken. Summation to integral calculus. There is nothing in written in the book. Summation to integral calculus. Anyone can search any book. All are here and there. Something imagination and something imagination there also. Wow, how we go ahead solving a problem. How we go ahead solving a problem, dividing the problem into n part and then bringing in into the integral calculus. Okay, so that we will see. Okay, so concept is that we will see summation to integral calculus. What we were seeing, if we see the what we were seeing, I believe there was one assignment. What the assignment was, there was an assignment to solve a repeated summation through integral way. Repeated summation through integral way. What is repeated summation? Repeated summation is a to the power x. Summation sign I equal to 1 to n a to the power I. Makes sense? A. A is a constant. A can be anything. A is a constant and A can be anything. What A can be? A can be anything less than 1. Because if I add less than 1 repeatedly and multiplying its power, then certainly it will tend to 0. Okay, like A equal to 1 by 2. This is the example we had taken. Summation I equal to 1 to n A to the power I. Okay, if a to the power I, I'm sorry, summation I equal to 0 to n, not 1 to n. Summation, summation, summation I equal to 0 to n, a to the power I. Okay, now it would start with 1, 1 plus 1 plus a plus a square plus a to the power 3. I mean a to the power 0 plus a to the power 1 plus a to the power 2 plus a to the power 3 plus a to the power 4 a to the power n. What is the summation? Okay, this is what people try to understand. The solution is multiply this summation. Consider s equal to a to the power 0 plus a to the power 1 plus a to the power 2 plus a to the power n. Multiply s with a. It becomes as. Whatever I am going to talk, it is certainly not in the book and no one would dream to write that. No one would dream to write it about it also. It is that kind of thing. So now we can write A into S. A into S, if I write, then what it will become? A0 is 1. A0 is 1. So it becomes A. It becomes A plus A plus A square plus A to the power 3. 1 it will be more. Earlier it was A to the power 0 A. A to the power 0 plus a square. Now it will become a plus a square a to the power 3, something like that. If I subtract, it becomes s and in bracket 1 minus a. S minus a into s 1 minus a. S 1 minus a equal to equal to a equal to 1, because if I sub, this will also go to infinity and it will tend to 0. First one will also go tend to infinity, it will tend to 0. If I subtract, then a to the power 0 will remain 1. S equal to 1 by 1 minus a, provided it converges, a is less than 1. Then S equal to 1 by 1 minus a. Okay, if a is 1 by 2, then it will become 2. If a is 2 by 3, then it will become 3. Make sense? If a equal to 1 by 4, if a equal to 1 by 4, it will become 4 by 3. I think so. Okay, 1 by 2, 2. 2 to the power 2 by 1. 2 by 1. 2 by 3 means 3 by 1. 1 by 4 means 4 minus 1, 3. 4 by 3, 4 by 3. This is what this is what I think so. Okay, it will be 4 by 3. Okay, now question is arising that can someone solve? Okay, where we need calculus? Here probably we don't need calculus. But anyway, this is a very big example where n can be tends to infinity. If n is not tend to infinity, then it is really difficult to find here. If n not tends to infinity, it is really difficult finding here. How much it is? If I say summation I equal to 0 to n, a to the power n, where n is 100, then we cannot imagine that this solution will not work. Make sense? This solution will not work. S the sum is summation. Summation means sigma sign. Sigma sign I equal to 1, I equal to 0 to n, a to the power n, where n is 100. Okay, if it is 100, what is your a? Consider a is 1 by 2 only, then it will be 1 by 2 to the power 0. 1 plus 1 by 2 plus 1 by 4 plus 1 by 2 to the power 100. It is insignificant, but it is not 0. When it is 0, when n tends to infinity. Summation of I equal to 0 to n, where n tends to infinity, 1 by 2 to the power n, then it will go towards 0, certainly. If n tends to 0, infinity. But if n is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, we cannot say that it is 0. Then no one can find a solution. It will be, I believe it will be difficult in this fashion. Okay, consider it is a to the power 0 to the power to 10. Okay, then it will be 1 by 2 to the power 0 to 1 by 2 to the power 10. If I multiply by 1 by 2, it will become 1 by 2 to the power 1 by 2 to the power 11. If I subtract, then it will become, I believe, 1 minus 1 by 2 to the power 11. Okay, it works here also. 1 minus 1 by 2 to the power 11. 1 minus 1 by 2 to the power 11. Okay, divided by 1 minus a. Divided by 1 minus a. This is what I think so. Okay, means if someone is trying up to 100 also, first term, that is a to the power 0 and a to the power 100 will remain. A to the power 100, 1 will remain. I believe it is solvable in this way also. Any concept is that how we can turn our calculation, that is a summation, into integral calculus. Summation into integral calculus, how we can bring in our formula. If I have a summation I equal to 0 to n, a to the power I, if this is summation, repeated summation to integration, that is the question now, how I can do. Okay, now we saw few things here. If I say, okay, so consider the whatever I am mentioning now, it is not available in any of the book. Okay, this is mind blowing thrilling. That is for sure. Okay, now I have x-axis and this is origin. This is 1, 2, 3, 4, 5, 6 and onward. Now I have a curve called 1 by 2, 1 by 2. 1 by 2 to the power x. Makes sense? 1 by 2 to the power x. It will come like this. If I if I don't take this part, it will come like this. At origin, it is 1. As I go along, the height is decreasing. Okay, now I am making I am doing sampling of this height at integer point x equal to 0, then I am taking a height. When x equal to 1, then I am taking a height. When x equal to 2, I am taking a height. When x equal to 3, I am taking a height. When x equal to 100, I am taking a height, like that. If I add all these heights that come as I equal to 0 to n up to n, okay, a to the power or 1 by 2 to the power I, that is the height. So if I have a function and function is 1 by 2 to the power x, now I am doing a sampling. This is x-axis. If I am doing a sampling when x equal to 0, one sample, that is 1. 1 by 2 to the power 0 is 1. When x equal to 1, one sample. When x equal to 2, one sample. If I add all these sample, how much it will be? We saw it will be it will be 2. I think so. It will be 2. How it will be 2? Because the net summation is s equal to the net summation x equal to 1 by 1 minus a, that will come as 2. So this value is 2. Now any can take, it is 1 by 1 minus a. Anyone can take any value. If a equal to 1 by 10, then it will come as 10 by 9. Okay. If it is 9 by 10, then it will come at 10 by 1, 10. Okay. That is the concept that we are pursuing now. Now the concept is when n tends to infinity, this can be a fit candidate. This can be a fit candidate to convert into integral calculus. Okay, if I'm trying to convert into integral calculus, what we have right now? This session is about how to convert any summation into integral calculus. Okay, in that fashion, I have summation I equal to 1 to n and function over function over I. What is function over I is 1 by 2 to the power I. Okay, I can say like summation x equal to summation or I can rewrite as summation I equal to 0 to n. If I have said anywhere I equal to 1, it should be considered as I equal to 0. Summation I equal to 0 to the power summation I equal to 0 to n. Now function over x, where x belong to ith section. If I have x-axis and it is going 1, 2, 3, 4 to any ith section, that is function over x for the ith section. I can say 1 by 2 to the power x, that belongs to ith section. So x for the ith section will be I only, because we have taken 1 gap. X equal to 0, 1, 2, 3, 4. If x and y are same, because x will also go 1, 2, 3, 4, I will also go 1, 2, 3, 4. Means x and y are more or less they are same. Summation I equal to 0 to n function over x, where x belongs to ith section. That is 1 by 2 to the power x, where x belongs to ith section. If both are same, coinciding each other, 1 by 2 to the power I. How I can bring into integral calculus? If I try to bring into integral calculus, then consider this summation is equal to integration sign, that is limit sign, x equal to begin to end. Okay, x equal to begin to end. Here x equal to I equal to 0 to n, where n tends to infinity, and I and x are same. I can write as x from 0 to infinity. G is a function over x, gx dx. Makes sense? Why gx dx? Because here I have only fx. Fx is the height. Fx is the height. If I want integration, the normal form of integration is limit sign gx dx. Or it is different than adding all the heights. How it is different than adding all the heights? If I try to do so, if this is x-axis, this is x-axis, and this is x-axis, and this is y-axis. Okay, this is x-axis, and this is y-axis. If that is the case, then this I can say function over x-axis. If this is x-axis and y-axis is like this, then if I draw any graph here where y equal to something x, like this graph, y equal to 1 by 2 to the power x, this is the graph. Okay, don't consider beyond my hand. So like this. So this is the graph that is 1 by 2 to the power x. 1 by 2 to the power x. When x is 0, it is 1. Otherwise, it is decreasing only. 1 by 2 to the power x. Means this height, this y is function over x. Y equal to 1 by 2 to the power x. I can write as y equal to function over x. Okay. Now this is function over x and this is x axis. This is the graph. Function over x if I take, then this is the graph. Make sense? Now, I am saying that I have taken sampling at integer point on the x-axis, x equal to 0, 1, 2, 3, and take the height in the fx, and that will become summation I equal to 0 to n, where n tends to infinity, function over x, x at in the ith section. Now that we are adding, I want to calculate this through integration. I don't want that vague method now multiply with the a and then subtract it and divide. This fundamental is called tricky fundamental. It will not work everywhere. But whatever we are talking now converting into integration, it will work everywhere, provided n tends to infinity. Okay, we have talked about this in the past video also. Now, if I talk about integration, okay, then I'm sorry, if I talk about the integration. Now, I can rewrite the first one. First one is summation I equal to 0 to n function over xi into 1. What is 1? 1 is delta xi. Delta xi is delta xi is the gap between, hope I'll retry it. So this is x-axis and this is function over x. This is function over x. If I take at any x and go up, it hits the function. This is function over x. This is x plus 1. If I go up, it hits the function over x. This is x plus 2. I go up, it hits the function over x curve. Okay, now I can multiply this function over x with 1. I can multiply anything with 1. If I multiply with 1, I can rewrite this summation formula. I equal to 0 to 1 function over x belongs to ith section, into 1. What is 1? 1 is gap between two heights, two sample, and that is 1. So 1 I can write as delta xi. Delta xi means if this is x-axis, the gap between two heights. Okay. If this is x-axis and this is the curve we are talking, that is 1 by 2 to the power x. Consider this is the curve that is 1 by 2 to the power x. Now at one point, at point x, I have drawn a vertical line. And at point x plus 1, I draw a vertical line. This is smaller. Okay, in that case, now the gap what we are seeing here in between these two lines is 1. That I am denoting it as delta xi, the gap of the ith section, that is fortunately 1. Okay, now we can rewrite as summation I equal to 0 to n function over xi into delta xi. Okay, if I have this kind of situation where I have function over x multiplied by delta x, means if I have sampled a function at different point, and at one point I have the height and then it is multiplied with the width, more or less it is giving one illusion that we are calculating the area of the strip. Height into width is area of the strip. If I add all the area of the strip like this, earlier we had addition of the height only. Summation I equal to 0 to infinity, or n tends to infinity. Function over x, and x belongs to ith section. Okay, this is only the height summation we are doing. Deliberately we multiplied it by 1, no problem. If I multiply it by 1, luckily 1 is the gap between each height. Each sampling I have taken, the gap between them is 1 only. So gap I can write at delta xi. So height into gap is the width of this subsection. If I have a graph like this, if I have a graph, if I have a graph like this, and this is x-axis. I have a graph like this. Then if I take any point here and another point here, and then I draw a vertical like this, it will go up. This is the one area of the strip of the graph. Like that, I can go keep adding all the strip because they are non-overlapping. If I add all the area, it will be the area underneath this graph. So summation I equal to 0 to n tends to infinity function over x into delta xi. It is same as fx dx summation x equal to 0 to infinity. Because there also we are calculating the area. In summation, we are calculating each ith section area by multiplying height with the width. Okay, and if I add all the summation, it becomes the area underneath fx. That is actually better can be represented as fx dx. Now I can do the integration. We have done in the past video also. Now x is 0 to infinity fx dx. What is your fx? That is 1 by 2 to the power x. So a to the power x integration is a to the power x by logarithmic of a. This we have proved in the previous video, that how integration of a to the power x is a to the power x by natural log of a. So integration will come 1 by 2 to the power x by natural log of 1 by 2. X is 0 to infinity. So if I put infinity, then 1 by 2 to the power infinity will be 0, minus, and then 1 by 2 to the power 0, that is 1. 1 by ln, 1 by 2, that is ln 1 minus ln 2, minus minus positive. I believe we have taken down as minus. So 1 by ln 1 minus ln 2, minus minus positive. So 1 by ln of 2. Ln of 2, I believe ln of 2, I believe it is 0.69 or something like that. 0.7. It will be 0.7. So 1 by zero point 0.7 is the result. It will come as 1.4. So 1.4 is the repeated summation. If I take summation I equal to 0 to n, and then we took 1 by 2 to the power x. Okay, that summation is 2. Here by integration I am getting 1.4. Anyone would also thanks God I did not use calculus. Otherwise I would have messed up and I would have come up with the wrong solution. So solution through integration is 1.4, where solution through simple algebraic way is 2, and that is perfect, looks like. Where is the problem through the integration? We did till here only in the past video. What is the problem through the integration? The problem with the integration, problem is not with the integration. Problem is the way we converted our repeated summation to integration. If I see the repeated summation, then at any point I have a bar height, and if I multiply with the width, then it gives the area of a rectangle. Then another section I am going, then there is a height that is smaller now, because 1 by 2 to the power x. Then by width, it is giving area of one rectangle. Actually, we are adding all the rectangles to come to the net solution, and it is coming as 2. Whereas if I take this as a continuous function, that is integration, if I take this as a continuous function, then continuous function divide this area into infinite chops. Okay, n tends to infinity means infinite chop, and then one chop area it tries to calculate and then add all. If I take one chop area, if I take x equal to 0, then height is 1. If I take x equal to 1, then x equal to 0, then height is 1. Okay, if I take x equal to 1, then height is 1 by 2. Okay, I'm taking this rectangle as the area. I'm taking this width, and then one side height is 1 and one side height is 1 by 2, and this side is a curve. This area we are calculating, whereas when we are calculating through the repeated summation, we were taking first rectangle as height as 1, width as 1. 1 is the area, where here is first height is 1 and then second height is 1 by 2 met by curve line, and width is 1. This area and rectangular area through the both are different. and both are different through the multiplication of 0.7 only. And that's how someone can try. If I see the area through integration any section, then it will come as, if I do like this, if this curve line I make a straight line, then it will come like this. This area will come like this, where there are two straight lines. One is 1 by 2, another is 1 by 2. Then there is a curved line, and this is again 1 by 2. One curved line, this is the area I am calculating through integral calculus. Whereas through repeated summation, if this is 1 and this is 1, or this is 1, then this is also 1, and area we are calculating. So it is lagging in this fashion. This area is going away. Means if there is a curve like this, then this portion, other portion area is going away in the integration. Anyway, so integration, how much it will be? If I take 1 by 2, 1 by 2, area will be 1 by 2 into 1, base 1 by 2. Top, if I take area, then it will be 1 by 2 into 1 by 1 by 2, because there is triangle. I have taken a straight line. 1 by 4. 1 by 2 plus 1 by 4 will come as how much? 1 by 2 plus 1 by 4. 3 by 4. The area will be 3 by 4. Okay, 1 by 4, 4, 2 plus 3 by 4. So 1 by 4 we are missing. 1 by 4 we are missing in each section, that is of width 1. Okay, so the result what we are getting is 3 by 4 of the result. So here we are getting result as 2, where here we are getting result as 1.4. Okay, 1.4, I think so. Okay, 1.4. Actually, it is 0.69. This is what I think so. It will come as 1.42 or something like that, whatever it is. Now, if I multiply, and we have taken this as curve as a straight line, what we are calculating, the area, the actual area will be less than that, 1.4 or something like that. I don't know how much it is, more or less. Now, here it is 2. 2 multiplied by 3 by 4. 2 multiplied by 3 by 4. Okay, it will come as 50. So near about it, because we did approximation for the curve line, straight line we did. So it will come as a 15 only if we take accurately. Means this much we are losing. Because integration calculus is not something that you would lose. It should, calculus is not approximation. Calculus is exactly perfect science. There is not even a one part per million. In 1 million, one error can be tolerable. In calculus or mathematics, even 1 in 1 billion error cannot be tolerable. That is mathematics. It is completely fixed science. Okay, tends to. There is no tends to. It should work. What tends to? It is more precise than anything else in the world. That is mathematics. Okay, okay, don't boast. Prove it. Anyone would ask me, prove it. Okay, where things are lagging is that we took width as 1. Okay, whereas if I want to transfer a repeated summation into integral calculus, then height by width is the area. This area will be equal to the area what we take in integral calculus if this width tends to 0. This everyone understand. If I have taken a repeated summation, and then in repeated summation I multiply height with the width between two height, that width is very small. Consider it is infinitesimally small. It tends to 0. Then whatever area we are calculating, that area what we are calculating, anyway, it is area of rectangle only. But in integral science, we have area of a curve line. Top part is a curve line where bottom part is 1. But if bottom part width is extremely narrow, tends to 0, then it will tends to become a rectangle. Then someone will say, again you started tends to, we will see. Right now base, keep basing. So the repeated summation and integration, they will become one, same thing. If the delta xi what we took as 1 tends to 0. But how come it will be tends to 0? We have summation I equal to 1 to n, 1 by 2 to the power x, where x belongs to is section. So 1, 2, 3, 4, 5, 6. the base width between two height snapshot is 1 only, and 1 cannot be said that tends to 0. Okay, it should be tends to 0 if we actually want it to convert it to integral calculus. Okay, now let's take again. Let's take a x-axis where we have 0 and 1. Make sense? Now chop it into n part where n tends to infinity. Now again equation is same. Again equation is same. Summation I equal to 0. If I have said I equal to 1, then I equal to 0 to n where n tends to infinity. 1 by 2 to the power I. 1 by 2 to the power I, or x, that belongs to ith section. Makes sense? Now this I am saying fx. Now I can write this as multiplied by 1. Multiplying with the 1 is there no harm. But now this is not the area of the ith strip. If I take ith strip, this is x, where x goes from 0 to 1. If this is the ith strip and here the height is fx, means 1 by 2 to the power I for the ith strip. Then if I multiply with the 1, saying this is the area of a strip, this is not the area of a strip. Because x, if I have taken ith section, then if I go to I plus 1 section, the width between these two is 1 by n, because I have taken 1. 1 by n is width of the section. So not possible. The way we are saying multiply by 1, we can multiply by 1, there is no problem, but that is not getting. We have to find area of this strip. This area strip, if I get, then if I add for all, it will turn into integral calculus. So area of the strip is not this one. Okay, how we can proceed? I want through integration, because I want, when n tends to infinity, it is a perfect case to convert into integration. Okay, to get perfect case, I divided 0 to 1 in the x-axis into n different chop. Okay, if I make n chop where n tends to infinity, one chop has a width of 1 by n. Anyway, in n chop, at every chop, I have taken a snapshot. I have taken a snapshot, and that snapshot is integration I equal to 0 to n tends to infinity 1 by 2 to the power x. X belongs to ith section. I cannot write it as multiplied by 1. I can write it multiplied by 1 by n. Then I have to multiply back with the n only. So it will become n 1 by 2 to the power x into 1 by n. Now second half I can write it as integral calculus. But the way n is coming as numerator, I can multiply anything and divide by same thing. So fx into 1 by n into n. The 1 by n is the width. That is guaranteed. So fx into 1 by n is the area of this string. Now I can convert into integration now. Now it will become integration fx dx, x is 0 to 1. But in a word, we got numerator n. How to settle down n? N. So this way is not something that is promising. What is another way? Another way is I have to change this fx. The fx is 1 by 2 to the power x. Now I have to mold it to another function. Then only multiplied with, what is the concept I am trying to pursue now? The concept I am trying to pursue is, if this is the height, if this is the height, multiply by the width, give the area of this rectangle. This rectangular area should be same as if I do integral calculus and then I take a height and then I calculate this strip area. This strip area and that rectangular area should be same. This is what we are falling off. So they should be same. In that case, now the function will change now. Earlier we took this continuous function as fx only, 1 by 2 to the power x. Now I have to take a gx, so that the area of any strip, if I take, what is area of any strip? If I have a function called gx, what is area of any strip? Area of any strip. Okay, now I have divided this strip into different sections. What is area of any strip? That is gx dx, gx dx. If I take x, then x, if I divide into many sections, then x equal to one section to x equal to section plus 1. Makes sense? Okay, what are you trying to say? What I'm trying to say that earlier we had fx. Earlier we had fx. If I go back with the fx only, then fx into width, fx into width, that was a rectangular region. Okay, here if I do fx into width into integration, then it does not come as a rectangular region. Okay, when this gap tends to 0, then more or less there will be same. That is the one scenario that we will see. What is another scenario? What is another scenario? Another scenario is I'm going to change fx into another function gx. And then if I calculate the strip area, it should be same as fx into 1. Okay, that is the concept. The main concept for bringing integration is the gap should be very less. Okay, anyway, so that is the ideal concept that we are talking. The ideal concept should be integration. I'm sorry, summation I equal to 0 to n fx, summation I equal to 0 to n, where n tends to infinity, fx. Okay, where we have taken 0 to 1 and we chopped into n part. Now each part is very small. Okay, now if I say fx, if I change fx somehow, if I change fx into gx into 1 by n, makes sense? If I change fx into another function called gx, so that fx into fx will transform into gx into 1 by n, where n is 1 by n is the width. If that is the case, then I can write as gx dx x0 to 1. Makes sense? Repeated summation I equal to 0 to n tends to infinity, fx, where x belongs to I as section. Now this I cannot write as fx into 1, and this is the area of a strip because width is 1 by n, where n tends to infinity, and this width is 0. This is a perfect case to bring into integral calculus if I can rewrite fx as gx into 1 by n, and 1 by n I can write as delta xi. Now gx into delta xi, where delta x is the width and gx is the height, it can be transformed into integral. This is the better way. So we have to change fx now. Anyway, let's go to the previous problem. So this is the idealistic case. This is the idealistic case. Or I can rewrite what we have written here now. What we want. Fx equal to gx dx. We are changing fx now, then only integration is possible. With same integration where the cut is 1 1 1 not possible, then we have to take 0 to 1, 0 to 10, whatever it is, cut into n part, and one section is 0 width. Now it's possible. In that way, gx will be transformed in, I'm sorry, fx will be transformed into gx. Now fx equal to gx into delta x, where delta x is 1 by n. What is gx then? Now I can write as integration gx dx from x is 0 to 1. Let's go back now. Our beginning problem was fx was the height and gap was 1. Okay, now we can write as, now here we have gx dx. Okay, now take any section. Take any section. If this length is x, then another length is x plus 1. This length is x, then another length is x plus 1. I believe this is what it is. Okay, in that case, what is the area of this? This is integration of gx. Limit x to x plus 1 will give the area of this strip. Makes sense? So we have integration x to x plus 1 gx dx is same as fx into 1. That is the area of rectangular strip. That area of the rectangular strip which has width 1 in earlier problem. Okay, now it turned into gx dx new function. Gx dx integration x equal to x plus 1. One strip that should match the area, then it will work. Okay, now we have fx equal to integration of gx dx, means gx equal to differentiation of fx. Makes sense? Okay, means we have now integration. So gx is differentiation of fx. I can rewrite as integration x equal to x plus 1 fx. instead of gx dx. Oh, I'm so sorry. D of fx. Okay, if that is the case, then what is differentiation of fx? If I do differentiation, then dx will go away. Gx will become differentiation of fx. What is differentiation of fx? Or I can say fx is equal to gx dx. Dx is equal to dfx by dx. Okay, if that is the case, then what will be fx? Gx now. Differentiation of fx. What is differentiation of fx? A to the power x differentiation is logarithmic a into a to the power x. Makes sense? Okay, now we have now gx equal to logarithmic a into a to the power x. Okay, that is the gx. Now limit that is x to x plus 1. Let's solve this limit now. If I solve this limit that is x to x plus 1, it will become ln a to the power x. So ln a to the power x plus 1 minus a to the power x. It will become ln a to the power x a minus 1. Okay, a minus 1. Okay, if someone settled down a minus 1. So right side, if I say gx dx integration is a to the power x, integration is ln a to the power x, means gx dx, if I integrate gx dx into integrate, then gx is coming as hop gx dx is fx. Gx dx integration is fx. So gx is coming as differentiation of fx. That is ln a to the power x. Okay. Now gx dx is coming as a to the power x. Something like that. Anyway, g hope I'm really sorry. Gx is coming as ln a to the power x. Okay. Now if I do reverse limit, okay, now the actual solution is x equal to x plus 1. Gx dx I'm finding in a reverse manner. Okay, in reverse manner, this solution lies with the differentiation of fx. Differentiation of fx. Gx I'm trying to find, right? Gx is differentiation of fx. So gx equal to ln a to the power x. Okay, now here the integration was x to x plus 1. Okay, if I solve this limit in reverse fashion, this limit will go as division mark. Makes sense? Here limit will go as multiplication mark. What is multiplication? A to the power x, a to the power x equal to x plus 1. It will become a to the power x plus 1 minus a to the power x. A to the power x will come out. 1 minus a will come as the extra thing. That will go as a division. Because we are doing opposite way. I have to find gx dx. I'm finding gx as differentiation of fx on the left side. Similarly, if integration x to x plus 1 is going as multiplication this side, that side it will go as division. So net solution that will come as gx equal to ln a to the power x by a minus 1. Anyway, someone has to work more on it. This is more or less like a differential equation, but more research is required. How to find gx in this scenario? Fx equal to fx into x1, fx into 1 equal to integration x equal to x plus 1 gx fx. In that sense, gx is the differentiation of fx. Okay, then if I set the limit, whatever the extra thing that is coming, the gx become ln natural log of a into a to the power x. If I set the limit x to x plus 1, a minus 1 is the extra thing that is coming here. That I have to divide to get the gx, because we are doing in the other way. So gx equal to ln a to the power x by a minus 1. Let's try integrating it. Let's try the work we started. Now we have summation I equal to 1 to n fx, or 1 by 2 to the power I, or 1 by 2 to the power x in the ith section. It becomes integration. become integration x equal to 0 to infinity, because we found that gx. We change it. So x equal to 0 to infinity, x equal to 0 to infinity, ln 2 to the power x by a minus 1. Okay, now if I said 0 to infinity, I'm sorry, if gx dx, what is integration of a to the power x? That is a to the power x by ln a. Ln a went over. The net integration has come as a to the power x by a minus 1, 0 to infinity. A minus 1 is 1 by 2 minus 1. That will come as 0 to infinity. Okay, 1 by 2. Negative someone has to settle down. 1 by 2. And 0 to infinity of a to the power x will come as infinity is 0, 1. 1 by 1 by 2, 2. 2 is the solution. Okay. How I trust you? Is it really true? Try. Who is stopping you? The new function in integration is gx, that is ln a to the power x divided by a minus 1 or 1 minus a, that will come as positive. 1 minus a, if we switch the limit here and there, 1 minus a. Try with 2 by 3, a equal to 2 by 3. If I try here, summation I equal to 0 to infinity 2 by 3 to the power x I, then it will become as a, through the previous way. The solution will become 1 by 1 by 1 by 1 by 1 minus a. Same thing here also. The solution is 1 by 1 minus a only. Okay, so for everything it will work. Try it. Okay, if people are very virtuoso and they are very nice, they can try for the 0 to 1 and dividing into n part, then limit will change. Try it. Makes sense? Function over x is the actual repeated summation. If I want function over x as integral calculus, and there is no dx here, there is no delta x here, then I have to change this function over x to gx, so that gx dx limit, now both will be on the same height. Function over x into 1, it gives the area of one strip. This area of the strip, one strip area, if I take, then here it becomes integration x equal to x plus 1, because that is the one strip. If any x and x plus 1, that is the one strip. That area of gx dx will give the area underneath it. X equal to x plus 1 will give the area of one strip. This should be same. Here it is fx into 1, and here it is gx dx integration x equal to x equal to x to 1 plus x plus 1. Now if I have fx equal to integration gx dx, then if I do differentiation, then differentiation of fx will become gx. So gx is differentiation of a to the power x. Ln natural log of a into a to the power x is the gx. That is understood. Now I have to settle down the limit. Now the integration of gx dx, gx we have found ln a to the power x. Okay, that is for sure. What we have received now, that the gx we have got it. Now we have to settle down the limit. We have to settle down the limit. If I settle down the limit, ln, leave the ln, a to the power x, a to the power x, x is x to x plus 1. If I do like this, a to the power x plus 1 minus a to the power x, it will become a to the power x, a to the power x 1 of a minus 1. It will become a minus 1. That I have to go, it will be multiplied here, that I have to go by division, because everything we are doing in reverse fashion. So gx would become differentiation of fx, and whatever we put the limit at, it came as numerator, that will go as denominator, reverse fashion. So gx would become differentiation of fx, and whatever we are settling down the limit, it will go as denominator. Gx will be ln a to the power x, that is differentiation of fx, and limit settlement is 1 minus a minus 1 or 1 minus a. This is gx. If I go ahead with the finding the integration gx dx, x is 0 to infinity. This is what we started. Then gx is ln a by 1 minus a to the power x. ln a 1 minus a to the power x integration a to the power x by ln a. ln a natural log. ln a gone. Or what remained is a to the power x by 1 minus a. Limit 0 to infinity. 1 minus a is constant, it will come out. 0 to infinity of any a to the power x will be 1 only. Infinity is 0 and 0 is 1. 1 by 1 minus a is the solution. That is exactly same what we got in the summation mark. Mind blowing, amazing, thrilling, head hitting in the wall. Someone can try. Okay, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is India country code. 9483160610 is the telephone number.